listen-only mode.
Hello everyone, my name is Terry Erzman. I'm the Chief Marketing Officer for Percona. Welcome to today's webinar. We will be making a recording of today's webinar, and we'll send you a link to the recording as well as to the slides from today via email within the next 24 hours. So thank you for registering for today. If you have questions during the webinar, please submit them in the questions box in the GoToWebinar control panel. And just quickly, just to check the sound, if you can hear me all right, would you please raise your hand in the GoToWebinar control panel? Great, I see lots of hands raised. Thanks, everyone. Very good. So with that, I'd like to introduce Peter Boros. He is speaking today on Percona XtraDB Cluster installation and setup. And Peter, I turn it over to you.
Hello. Good day, everyone, or morning, good evening, or whatever daytime is for you right now. So I will speak today about Percona XtraDB Cluster, with focusing on installation and setup and focusing on the basics. I want you to understand how it works, and I want you to be able to configure it. So we have an agenda today. So we will install and configure the first cluster node. We will connect the subsequent nodes to the first one. We will use an application server which will run HAProxy, which will load balance between our database servers. And we will test with sysbench as a real-world database application. And we will break and fix the cluster in many ways. Okay, so this webinar will be hands-on as much as it is possible with the webinar. So we won't only see slides, we will actually see XtraDB cluster in action, and we will build it and break it and build it again and break it again and understand why it behaves like it behaves. Okay, so the goal of this talk is to make an introduction of XtraDB cluster with a more hands-on approach. We will use freshly installed CentOS 6 VMs, which are vanilla installations. So this webinar will cover installation from the very beginning. Although we won't do everything live, but we will cover everything. And we will cover load balancing using HAProxy on the application server. Let's talk a bit about Percona XtraDB Cluster. In Percona XtraDB Cluster is a little bit different than other clustering solutions you might use. For example, you might use DRBD or MySQL with shared storage. You might use replication. XtraDB Cluster is not like that. In XtraDB Cluster, all nodes are equal. All nodes have all the data, and replication is synchronous. And this is very important because you won't have issues like slave lag and other issues like data inconsistency, which can happen with asynchronous replication. A cluster is made from at least 3 nodes, or another possible configuration is 2 and an arbitrator. We will use a cluster of 3 nodes as this is the recommended configuration. So first, we will install packages on all database servers. To do that, we have to add Percona's YAM repository and install the XtraDB cluster packages with this YAM command on the slide. I didn't want to show you too much progress bars, so these are already on the boxes. Okay, so the packages are already installed. Can you use the raise your hand button if you see the terminal window, or shall I make the font bigger? Okay. Okay, so this command above installs the following packages. So these are needed. When you yum install, you can check that these are really installed based on this slide. And the next step after installing is configuring the nodes. In the configuration part, we have some XtraDB cluster specific information, but I would like to focus on getting things running. So the most important configuration parameter is WSREP cluster address. If you set it to just gcom:// it will initialize a new cluster. It is called bootstrapping. If you are starting a new cluster, a first node should be started with this option. If you are not starting the first node, but one of the subsequent nodes, you should use the same parameter with an IP address. The port you can read on the slide is the default port. And when a node is started with this option, it will connect to the IP address specified, and it will join to that cluster. Apart from this, we have the WSREP URLs option, which is a MySQL DCA option. It's not an option for the MySQL server itself. It gets a list of these addresses. You can read the example here, and it connects to one of them. So if you want to unify your cluster configuration, you can do it with the WSREP URLs command. Okay, so here is a minimal configuration of an XtraDB cluster node. Actually, it's not quite minimal because you don't need to have binary logging. Okay, an XtraDB cluster can replicate without writing binary logs, so you don't have to turn this on explicitly. But we turned binary logging on with log slave updates. We are specifying a few other options, like where is the WSREP provider, the shared object file which does all this. We have the WSREP slave threads option set, which is how many threads should we use for replication. Since XtraDB cluster uses global transaction IDs, it is possible to have parallel replication, and it's as easy to configure as this. The WSREP cluster name option is a name for the whole cluster, and the WSREP node name is a unique name for the node. The server ID in our case, which is the very first option in this example, is not that important because it is only used for conflict resolution in asynchronous replication. Our important parameter is WSREP node name. Our next option is WSREP SST method, which is extra backup, and we will get to that later. And we are using some InnoDB options to make Galera work. If we are configuring the subsequent node, you should note that this is changing, okay, the WSREP cluster address. So let me show this to you live. So we don't have MySQL running, and we have this MySQL configuration. Okay, and now I will start MySQL. If I check the error log, I see Galera related stuff here. And if I log in, I see that this cluster contains one node right now. I move to the second node, and let's check my.cnf there. I have WSREP cluster address here set to the first node, and I have an error in the configuration file because the node name has to be unique. And I start my SQL server. Since we have to guarantee for synchronous replication that all nodes have the same data, in this case, SST mechanism kicks off. SST stands for Snapshot State Transfer, and we have a new file here, which is innobackup.backup.log. What happens now is that if we check the process list, if we check the processes on this host, XtraBackup does a backup. XtraDB Cluster does a backup with XtraBackup from this machine, copying over to the other machine. Okay, and we can check the progress by checking this file, so we can see that this is a regular XtraBackup output. On the other end of the SST, we can see that it's not yet completed, but it is now. Why did it take longer than the backup completed? And the reason is that we have to do the apply log step of XtraBackup. So if we check this file, we can see that this is an innobackup-x -- apply log. It's like what you use regularly. And let's do the first node, the third node, with setting a unique WSREP node name and connecting to the first node. Here I specify to connect to the first node. But before doing that, let's switch back to the second node a little, and let's examine the size of our cluster so far. And the size is 2. All XtraDB cluster related variables are starting with WSREP. We can examine the local state and the local state comment, and we can see that this node is synced right now. So let's start our third cluster node, which will also connect to the first one, take an XtraBackup, copy it locally, do the apply log step, and it will join the cluster. And what is interesting that if I repeat this here, I already see that the cluster size is 3, although the PXE3 node is not yet ready. But it can participate in voting from the very beginning. And by voting, I mean what nodes should be parts of the cluster and what nodes shouldn't. Okay, so if we wait for this to start, we will have a perfectly healthy 3-node cluster, like it's advisable to have that in production. There we go. So if we create a new table with just an integer column, and insert some test data here, because we are replicating synchronously, Okay, I did something wrong. No, I didn't. The SST is still running. Okay, so we will have this table here. This is good. Okay, the issue here is why the SST is not successful is that I don't have NTP server configured on these virtual machines. And let's hope that this revealed a very important production issue, that you always have to synchronize the clock of the nodes. So let's install NTP now. On the nodes and synchronize the clock, and that way we can continue the demo. Okay. Okay, let's see. Okay, since this node is completely cloned at startup time, it's safe to just kill everything, just delete everything, just yum install NTP. And then synchronize the clock. And we have to do this on the third node as well. Okay. Okay, nothing is running. This will fail as well. Okay. Okay, I know what is the issue. So because we had two nodes, the first node became a minority. I actually wanted to show this later. And we have to bootstrap it again. And after this, we will be able to start these guys. So what happened here is we have a cluster of 3 nodes, and with the cluster of 3 nodes can have a split brain state. So in order to prevent split brain, XtraDB cluster will just shut down nodes who are not seeing the majority of the nodes. And since we have had the 3-node cluster, XtraDB cluster decided to shut down node 1 since it's lost connectivity to 2 other nodes, but that was because we killed it. So if we check it now, it is doing the SST, and it will do the SST successfully. At least let's hope for this. This is promising. So we have the data here, and we actually have a working cluster. Okay, I wanted to avoid this kind of demo illness so much that I did all these things a few hours ago and left my virtual machines running, and this is why the clocks are skewed. So sorry about this. Okay, so we have a working cluster now, and what we will do with the working cluster is we will destroy one of the nodes and see if the cluster is still available and if we can bring it back online. And we will destroy it the hard way. We will destroy it with crashing the Linux kernel underneath the node. So we have this up too. Okay, and we have the data. And what you should take away from these issues is that synchronizing the clock on the nodes is really important. Okay, it was all because of that. Let's crash this node. Okay, this is a manual kernel panic, and I will just reset the machine. So this node is no longer alive. And the other 2 will notice this. WSREP cluster size is now 2. Okay, we have a 2-node cluster. And since they are in majority, so we have 2 nodes from the 3 nodes, we have 2 nodes from the 3 nodes, they are still serving the data. But what happens if I am mean enough to node 2 and destroy that also with that command? And in that case, and in the meantime I reset it. And in that case what happens is node 1 will declare itself dead sooner or later. Oh, okay. It didn't, because node 3 started while I was talking and stopping node 2. So the whole thing was alive. Okay, but I showed this to you that, okay, let's crash both at the same time. You can see that once you got it working, because of clock errors, it's really hard to kill XtraDB cluster. And if I write on node 1 now, it just won't be successful because it tries to replicate to the majority of the nodes, which just won't succeed. And in these cases, we will get the unknown command error message, right? So let's reset this, and the cluster will bring back itself live because we have MySQL starting automatically. And in the meantime, let's see what happened here. So we used an SST to clone a node and to make it part of the cluster. And what we saw, when only one node was up, it didn't serve the data. It could serve the data because each node has all the data, but it didn't. And it didn't because it wants to prevent split brain. It wants to prevent data inconsistencies, right? So what we saw is that we have a 3-node cluster connected to some network, and what PXE1, the first node, saw is this, that it's alone. But for in this situation, I have a slide missing. So yes, in this situation, there is no way for PXE1 to decide if the two other nodes are dead and it's safe to continue to operate, or just the first node is isolated from the network. And if the first node is isolated from the network and it continues to serve the data, when you have application servers connected to it, the application servers can write that node, and the other application servers who could connect to the other cluster can write the other cluster. Okay, so that will mean that you will have inconsistent data because you are not running one but two clusters because of a network split. So in order to prevent situations like this, nodes in majority, so for the cluster to be up, we should have more than half of the nodes up. So it makes sense to have a 3-node cluster, a 5-node cluster, a 7-node cluster, right? A 3-node cluster is functional with 2 nodes, a 5-node cluster is functional with 3 nodes, etc., etc. If we have only a 2-node cluster, it won't be able to handle a split brain situation. And with the default behavior, with a 2-node cluster, when the first nodes, when one of the nodes shut down, the other will shut itself down because it doesn't see the majority of the nodes. You can configure it to continue to operate in split brain mode, but it's really, really not recommended. Okay, so let's see how can we connect to the cluster from the application side. From the application side, you can use driver level load balancing, like for example, you can use JDBC if you have a Java application to connect to multiple servers at once from the driver. But for the rest of us, usually an external solution is necessary, and an external solution usually have different kinds of advantages. We will cover HAProxy here, and with and we will use an application server, which is here, with HAProxy to connect to the cluster with sysbench. So let's see what HAProxy configuration we will use. If you read my blog post about this kind of setup, this should look familiar to you. So we are defining two backends. The first backend is PXE back, and the second backend is PXE 1 node back. For the first backend, we are specifying that we are doing TCP checks. So we are only checking, we are only load balancing at the TCP level. Okay? HAProxy doesn't know anything about MySQL wire protocol. but we are using HTTP for checks, and we have 3 servers defined. We will use them in a round-robin fashion, but whenever a new session comes in, it will go to the node which has the least connections. Okay, that is what balance least can do. The second configuration is a little bit different, and it is called one node, because this configuration or this backend will allow only a single writer, not multiple ones. So if we only have a single writer, so we will use PXC1. If PXC1 is out, we will use PXC2. If PXC2 is out, we will use PXC3. This is useful because if you write on multiple nodes, because of conflict resolution in Galera, if you have conflicting transactions, for example, you update the same record on 2 different nodes simultaneously, one of the transactions will be rolled back. There is nothing wrong with this if the application handles it. Usually the application should handle rollbacks. But if it doesn't, then you can fall back to writing on only one node. And apart from that, if you are expecting many conflicting writes and expecting many rollbacks, most likely it is better to use the configuration with only a single node, because in that case, that single node, it just won't happen on the single node, and rollback is a relatively expensive operation in terms of I/O. So for the application server node, we used CentOS 6 base installation, installed HAProxy from the EPEL repository, and used sysbench 0.5 package made by Fred. And let's demo load balancing here. So let's check the HAProxy configuration first a bit. So I only showed you the backend configuration because that is what is important, but here are the front-end definitions. So if we are connecting to 3303 port localhost, we will end up on the cluster connecting to all the 3 nodes. If we are connected to port 3306, which is the default, we will end up connecting to the cluster using one node only. And we are defining a statistics backend. So if we go to the address of this box, and if we start HAProxy actually, using the credentials supplied in the configuration file, we will have the HAProxy statistics. And right now you can see that all the nodes are red, all the nodes are down. Let's see why are they down. We can examine if the cluster is up. No, it's not, because we have to bootstrap this first. And then connect the rest of them. Let's wait for this. Yeah, and if I start two of them like I did now, it just won't work because it sets the cluster size to 3. Okay. This is cloned already. Let's see this. And we have the data here. Okay, and what we are using here is a script supplied with Percona XtraDB Cluster, which is cluster check. Okay, you can use xinetd to use this cluster check script, and if you check the cluster check script, it needs a MySQL user to connect to MySQL. So let's create this MySQL user now. It needs the process privilege. Okay, and if we check cluster check now, we see that the node is synced. If we check the statistics now, we are seeing that the node was down but going up. Okay, is this visible, or shall I make it bigger like this? So the yellow state means that the node was down and going up, because we had, so 2 out of 3 checks is successful. PXE2 is up already in HAProxy, and we have everything up, okay, because we enabled the checks for HAProxy. This is because of this part in HAProxy configuration. So inter 12,000 means we are checking every 12 seconds, and rise 343, so to declare something up it takes 3 checks, to declare something down it takes 3 checks also. So, okay, let's start using sysbench. First, we should create the data used by sysbench. Okay, it will be replicated to the other nodes, and we are preparing a new table here. Yes, and we have to create the user. Okay, if we do it again, it will create our table which can use this. Okay, and if we start a benchmark, we are connecting to the cluster now through HAProxy because we are connecting via localhost, right? So if I check the HAProxy status page again, what we will see is that on the PS front end, you will see 8 sessions currently and 8 maximum. And we can also see at the server level breakdown that from these 8 sessions, 3 are going to PXE1, 3 are going to PXE2, and 2 are going to PXE3. So if we want to check manually, really we have 2 sessions here right now, okay, from sysbench. If we check this, we have 3 sessions from sysbench. So it works, it really balances the load. So let's stop this now and execute another benchmark. And that other benchmark will only be different by using port 3306, which is the single writer port. And let's see how HAProxy statistics will change. We're seeing globally eight sessions, but 8 sessions on the PXE1 node front end, right here. If we check, we have all the 8 sessions here. If we kill the node PXE1, what we will see on the application server is that sysbench will restart. Okay, we will reconnect. And it just won't reconnect for a long time. Let's see what is the reason for this in HAProxy, because node 1 is still in going down state, right? Because we have two strict checks for this. So we actually have to wait until it's declared down, and then after that the benchmark starts. Okay, and we can see that it will go to the first backup node, which is PXE2, and if we check PXE2, it really has all the sysbench threads connected. How can we fix this? Fixing this is relatively easy. We just have to edit the configuration file and set lower timeouts. For example, only 400 milliseconds. Okay, we set it, which should bring node 1 back up. But in this case, we can't bring it back up just like restarting MySQL, because since its configuration is in bootstrap mode, right, we will start a new cluster if we would start it like this. But we can use, for example, the WSREP URLs setting, where we can specify all the 3 cluster nodes, and it will just connect to one of them. And if we start MySQL now, the init script will return immediately, but MySQL is not yet ready. Let's see what does it do. So it is getting data from node 2 because we have a backup log file here. Okay, so right now it's cloning itself. And soon that database will be ready again. And when it will be ready again, it will appear as healthy in HAProxy. But now we have different timeout values configured. So the backup is done. And let's see, how did it go here? Okay, this is done also. So it should be live, yes. It has the data, and it should be up in HAProxy. So from here we will use that as a backend for sysbench. But now we have different HAProxy settings. So if we start this benchmark again, connecting to one node only, and you can see it doing transactions, right? If I kill MySQL again, it will have some failed writes, but it restarts almost immediately. The 5 seconds are some sysbench retry timeouts, and in HAProxy we can see the failover is almost immediate. HAProxy is a really, it has really many possibilities, too much to cover here. You can control failover times like this. So it is usually an issue that some people like fast failover, some people like to wait before failing over. You can configure it with HAProxy like this, but you can also have advanced options, like if you are adding a new node, you don't want to get all the traffic right to that node, but rather have some kind of ramp-up period. For example, to warm the buffer pool. So in the first time it will only get 10% of the traffic, after some time it will get 20%, etc., etc. So it's kind of a slow and graceful start. Okay. So this is what I wanted to show you today, and obviously without the demo sickness. And now I hand it over to Terry to have some questions from you.
Okay, very good, Peter. Again, if you would like to ask a question, please submit it through the questions box in the GoToWebinar control panel. We have a few questions. First of all, what are the steps to automatically restart a Percona cluster after an outage?
Sorry, can you say it again?
What are the steps to automatically restart a Percona cluster after an outage?
So if the whole cluster is down, or the whole cluster was down, the first step, what you should do is to make sure that all of the nodes are down, or more than half of the nodes are down, to avoid inconsistencies. The next step is to pick a node and bootstrap it. The bootstrap mode is just putting gcom:// in WSREP cluster address, and then start up the rest of the nodes normally. Most likely you will have the WSREP URLs parameter configured, so if you start up the other nodes, they will do the SST, and they will have the whole data.
Okay, and I think this is how. I think this is a related question.
This is how you restart it.
Okay, related question. I'd like to know if full SST is required for node recovery, or is incremental recovery an option?
Incremental recovery is an option. Frederick wrote a great blog post about this. Actually, we have two state transfer methods. First is SST, and the second is IST, and IST stands for incremental state transfer. Galera has a cache called Gcache. In that, it stores the incremental transactions as write sets, and if a node joins, so it will have all the write set required in the Gcache. then it will be able to start up with only applying the previous write sets. You can actually avoid the SST on purpose. For that, you have to use extra backup. Extra backup has a --galera info option. If you make a backup like that, the WSREP, so you will point to another class node, and after that it will be able to perform an IST most likely, because the write set identifier, which is consistent with the backup, will be stored together with the backup.
Okay, next question. In terms of fault tolerance, can you recommend a 3-node cluster for production use?
Yes, absolutely. This is the recommended configuration.
Okay. Next question. Can you quickly show the my.cnf settings again?
Sure. This has the WSREP URLs. I will leave this up until we are at the end of the questions, all right?
Okay, very good. Next question. How does latency and bandwidth affect performance? Is it practical to build the cluster over a WAN connection with approximately 5 millisecond latency?
Yes, it will work, but the weakest link in latency will determine the response time of the cluster. So if you have a 5 millisecond a node with a 5 millisecond latency, you won't have a single write transaction which will finish earlier than 5 milliseconds, because it has to make the round trip to that node, and the transaction actually doesn't have to happen on the remote node. It is enough if it gets certified. So write set replication is certification based, so we can do parallel apply, but if you have a 5 millisecond link, your writes will take at least 5 milliseconds. If you have a 10 millisecond latency link, your writes will take at least 10 milliseconds. However, this most likely will only affect response time, because we can replicate in parallel, and you can achieve the desired throughput with a parallel workload, despite that we have a relatively long response time. In terms of network latency, if you have a local network, if you have a decent network, XtraDB cluster can actually be faster than a single node DNOD, because a disk I/O on a spindle can actually be slower than a network round trip on decent network. So yes, for reads, network latency doesn't matter. Reads are always local. Reads doesn't involve network communication at all.
Okay. Next question. Do you recommend this configuration for servers in different data centers?
Yes, if you have at least 3 data centers. If you have 2 data centers, the issue is the same. And if you have 2 data centers, if one of them goes down, in the other, either the nodes will be in majority, then why did you have the other? But if the nodes will be in minority, then they will shut themselves down. So if you have 3 nodes and you want multiple data centers, you have to have 3 data centers if you want to be resilient in terms of data center failure.
Okay. The next question is, how would you migrate to XtraDB cluster from a traditional master-slave scenario when the data set is very large? Can you swap in binaries?
Yes. How I would migrate? I would go to the recorded Percona webinars website, and I would watch Jay's webinar about migrating to XtraDB cluster. But in a nutshell, you can configure one of the XtraDB cluster nodes as regular asynchronous slaves, and you can upgrade MySQL based on built-in MySQL asynchronous replication, like you would upgrade to new hardware or you would upgrade to new MySQL version, but this time you can upgrade to XtraDB Cluster. It has some caveats. It's not that simple, and Jay had a webinar about this with best practices. So that is how I would start.
Okay, next question. How does write performance scale with an increasing number of nodes?
Again, this is a question of response time. Okay, so a response time of a write transaction will have the response time of the weakest link. If we have more links, then we will have one weakest, even if we have very similar nodes. If we increase the number of nodes, the write sets are applied in parallel to the other nodes. So in theory, it shouldn't affect it too much. But we don't have measurements about this. In fact, what we have measurements about is if you write on 3 nodes, not only one, then if you don't have conflicting transactions, write performance actually increases, not decreases slightly. Where is that limitation? I'm sure there is a number of nodes from where it starts to degrade, but we didn't do a measurement like that so far. So I wouldn't do, for example, a 25-node cluster.
Okay, the next question. When one node in a 3-node cluster is synchronizing with the group, are the other 2 nodes available to serve data during the synchronization?
This is dependent on the SST method. If the SST method is extra backup, then it is. If the SST method is rsync, for example, then it isn't, because we have to log the database to get a consistent copy. Okay, for extra backup, we don't need that. In fact, if the node is a source of an SST, the cluster check script will take it out from HAProxy, but we have a variable here which is available when donor. If you are using extra backup, this is safe to set to 1, and if you set it to 1, the node will just return that the node is synced and you are able to do transactions on it.
Okay, next question. Does Galera async replication fit in with Percona XtraDB Cluster? In other words, can I run a production cluster in synchronous and a disaster recovery location replicated asynchronously?
Yes, you can. So, short answer, yes. Long answer, it is possible, but it has some caveats. So what you can do in this case is you have 2 clusters, and one of the cluster nodes on data center A will replicate asynchronously to one of the cluster nodes in data center B. If this node in data center B fails, you have to reclone the whole cluster in data center B. Actually, if you have very specific data and if you have the courage to do some manual mining, you can restart. It is possible to restart replication under certain circumstances, but there is no general way to do it. If this is interesting, I can write a blog post about it later, that in what circumstances can you restart replication in this case.
Okay, very good. Unfortunately, we are out of time. Thanks, everyone, for all your questions. We have many more than we could get to here during the webinar, so I will pass those to Peter, and he can blog about answers to as many of those questions as he can answer in a blog post here in the next few days. We did make a recording of today's webinar, and that we will send a link to that as well as the slides to you. There was also a question whether we could post the my.cnf file, which I'm sure we can get a screenshot of that for you. Last item, just like to mention, we have Percona Live New York, which will start which was October 1st and 2nd, and we also have Percona Live London, which is at the beginning of December. So if you're in the New York or London areas, please take a look at the conferences, and we hope to see you there. Peter, thanks for today's webinar, and thank you to everyone for attending. And again, we will send out the link to the recording and the slides within 24 hours. Have a good day.
Have a good day. Bye.